Okay, today we're going to review some more about functions. At the top of your worksheet, you have some examples of what are functions and what are simply relations. Okay, and a quick way to look at a graph and to determine whether it's a function is to use what? Vertical line test. Now, when we go to tables and equations, we're going to check what? Can you repeat that again? X values. We're going to check and make sure that each X only goes to one Y, okay? Or sorry, yes, each X only goes to one Y. All right. So if you look on the back of your paper, you have 4 equations, and we want to prove, okay. Oh, sorry, it's on the bottom row of the front. So back to the front page. Okay. There are 4 problems, and we need to determine whether or not these are functions, okay? So the easiest way is to plug and check and testing that theory that each X only plugs to one Y. So looking at the first one, Y equals X squared, is that a function? Yes. How do you know? Because it makes a parabola. You know what the shape of the graph looks like? Okay. How else can we prove it? You can plug in some numbers, okay? So you guys jumped right in that it makes this parabola, therefore it's a function. And we can also look at if I plug in the number 2, when I square it, I get 4, okay? If I plug in -2, I also get 4 though. Huh? Is that right? It's 2 different x's pointing to one y. Y is allowed to repeat, x is not, okay? So this one's good. Okay, looking at the next one, x equals y squared. Okay, so the first thing that I want to do is I want y by itself. So how would I do that? Square root. So that's going to be the square root of x equals y. Now, the rule is if you are taking the square root of something, you must take the positive and negative. If you are solving a problem and you are taking the square root, you must take the positive and negative. Okay? So, if I put in 4 here, right? The square root of 4 is what? 2 and 2. So 4 can go with 2, 4 can go with -2. Is that going to work for it to be a function? No, because I have 2 of the same x's pointed to 2 different y's. Okay? I could have also plugged in numbers right from the start, right? I could have plugged in -2, and that squared is 4. I could have plugged in 2 and squared it, it's 4. Now, it's something that I had to review, but the rule is if you are taking the square root to solve a problem, that's when you have to take the positive and the negative. That's why when we did the quadratic formula, or when you did the quadratic formula, the formula has the plus or the minus because you're solving for a squared. Okay? All right. Looking at number 3, I'm just going to rewrite it as y equals the square root of x. Now, do I have to take the positive and the negative here? No, because it's already there. So if it's already there, there should be a symbol. And what is the symbol? What type of square root do they want? Positive, because if there's no symbol in front, that means positive. Okay? So if I plug in 4, the square root of 4 is 2. If I plug in 9, I get 3. Is there any way to get a repeat? No, there's no way for my x to repeat, okay? My x is only going to give me one output. So this one, and I wasn't keeping track, let's go back. This was a function. This is not. This is. Okay, one final one. X equals the square root of y. I want y by itself, so what am I going to do? Square both sides. So x squared equals y. Okay? So, am I going to do any more work? No, why not? It's the same as problem number 1. So it is a function. okay? Again, somebody might say, oh, well, the square root of 9 is both positive and negative. No, because the square root because the square root is already there, I go with whatever sign is out front. I wasn't taking the square root. It already said square root. Does everyone see the difference? Okay. Something that you need to either add to that paper or to your notes, which you can add to your warm-up, is there are two restrictions. We're going to start talking about the domain and range of a function. There are two restrictions on the domain. Does anyone remember one of those restrictions? And one of them has to do with something we looked at up here. Navina. Okay, x can't point to two y's, okay? What type of functions did we kind of focus on up here? What operation did we kind of focus on? I square root, okay? And what did we know about square root? Under the square root. Yes, ma'am. Excellent. X has to be greater than or equal to 0 if I'm going to take the square root. It must be positive. Okay? Yes, I know you learned about imaginary numbers, but when we're focusing on domain and range, if I'm going to take the square root, the number underneath must be positive. Okay, when I look at rational functions, so something like x minus 3 over x plus 5, what is the rule here? What is the restriction? And this actually goes back to elementary school. When dealing with fractions, there's one no-no in fractions. What's the no-no in fraction? Yes, ma'am. I couldn't hear you, sorry. You don't, okay. You learned a rule about fractions. There's a big no-no. No, you can do that. What's a big no-no with fractions? Oh, you're going to see some of those this year. Yes, ma'am. Okay. It has something to do with a number. Where can't I have 0? No 0 in the denominator. So in this particular example, x could not be negative 5 because I can't have a 0 in the denominator. Okay? Good? All right, let's pause for a second. Okay, so now we're going to look at the back of the paper. And there's interval notation. Now, they are going to be flexible this year. I will quickly go over interval notation. I'm not going to spend a lot of time on it because they're accepting almost every form. They're not being very strict about it. But just so you know, when you go to higher classes, college, and different things, if it's a parenthesis, that means it's not included. It doesn't equal to. If it's the square bracket, that means it includes the number. So it would be a solid line or a solid dot. Okay? So this is not included. This is included. So this would say the interval goes from 5 to 8, but not including 8. So all the way up to 7.9999999. You follow? That's what this would mean. Good? All right. So I did not, for some reason, put these images on here. So we're going to go ahead and you're going to have to deal with my freehand. I'm going to do a couple with you, and then I'm going to have you do them on your own, okay? So the first one looks something like this. We have a parabola, okay? Domain is my x values, right? What is my lowest x value? 0. My lowest value on this one is right here, so 0. So I'm going to include 0 because the graph is solid, and it's going to what number? What number is it going to? Infinity. But not include, and that's because we don't know the exact stop, so I'm going to use a rounded bracket. Everyone good? Okay. That was totally wrong, guys. Why'd you guys let me do that? That is totally wrong. No, what is that? That's the range. You guys let me do that. That's the range. We did the height. My goodness. I shouldn't trust you guys. All right. So my domain is my x. And what x values am I going to use? I'm going to use all of them, all real numbers. So you can simply do this, or you can do negative, that's a negative, infinity to infinity. Sorry, guys. My goodness. Last time I trust you. Letting me make a mistake, not speaking up. Everyone okay with that? Range is my height. Domain is my width. All right, you ready to do the next one? Okay, we're going to do 2 more together. Here we go. This particular graph looks like this. And off the bat, what are you going to tell me? Not a function, okay? It's not a function, but we can still find the domain and range, okay? So let's try this again the correct way. Domain is which axis? X-axis. Okay, so it starts at and goes to infinity. So that would look like this. Okay? Now I'm going to look at my range. What's my range? All real numbers. Again, you can either do this, I'm fine with that, or if you're more comfortable with this, you can do that. Good? All right. Keeping it going? Okay. So the next one's easy. So I want to skip to another one that's a little bit trickier. Okay. So I'm going to move to the second row, first graph, which looks like this. Okay, so there's this curve, this parabola, this curve. All right, domain starting with the left. Over here, what number's all the way over here? Negative infinity. This one's really tricky, so pay attention. So I'm going to start at negative infinity, and then I'm going to hit a wall at what number? Negative 5. Okay? And then union symbol. You guys remember that? The union symbol. Okay? And then what do I have next? Negative 5 to positive 5, union 5 to infinity. You could have also said all real numbers except what? Negative 5 and 5. Okay? So this is interval notation. You could have also said all real numbers except negative 5 and 5. Is everyone good with that? Everyone see why? Why do I have breaks? What's there? Asymptotes. You're awesome. Okay, so now we're going to do range. And my range is going to be, oh, well, there's a gap. All right, so let's start at the bottom of the page. What? Negative infinity to, I'm going to say, not 0, I'm going to say 0.5. Okay? And then it's also joined with what? 2 to positive infinity. Okay, that was one of the trickier ones on the paper. Are we good? Oh, it's negative. That's right. Sorry. Thank you. Good catch. Are we good? Yes, ma'am. Because if you look at the graph, it hits like partway before the first. Okay. All right. In a moment, there are 5 graphs left. I'm going to let you go back and finish those, okay? All right. So let's do 2 algebraically. Oh, they gave you a picture. Well, we're going to pretend they didn't give me a picture. What rule does this break? 0 in the denominator. So my domain would be all real numbers except 0. Cool? All right, the next one is this. So my domain is going to be what? 0 to infinity. You can do 0 to infinity. That's one way. Or you could say x greater than or equal to 0. You could say all positive real numbers, however. We good? Okay. So what I'd like you to do is now take this moment to answer the 5 graphs that are left, the domain and range. Okay? I'm going to go through these answers fairly quickly. Here we have this graph, and the domain would be 0 to infinity, or x greater than or equal to 0 is another way to write it. The range is also 0 to infinity, or y greater than or equal to 0. All right? The next one is our split graph. And this one, you can say for the domain and for the range, it's all real numbers except 0. Domain and range, all real numbers except 0. If you wanted to do it in notation form, it would be negative infinity to 0, union, 0 to infinity, and that would be true for the domain and for the range. It covers the full graph. Okay? Moving on, you have one that looks like this with a slant asymptote. Okay, sorry, that's really sloppy. Okay, so I would have done for the domain, I'm going to go ahead and do negative infinity up to 1, 2, 3, negative 4, 1, 2, 3. For this one here, oh, sorry, I was doing the range again. You're right. Sorry, to negative 3. Union 3 to infinity. Sorry, I did it again. I was paying attention to the range. So my range, good catch that time, is negative infinity to negative 4, union 4 to infinity. Cool? Negative 5, 1, 2, 3, 4. All right, you want 5? I'll give you 5 on that one. And then positive 5 for the other piece? Okay, shh. Yes, ma'am. Yes, you can do all real numbers except, yep. All right, then you have the one that looks like a check mark. Whoop. Okay, this one is going to be for the domain. All real numbers except -1 and 1. All real numbers except -1 and 1. And my range is going to be all real numbers except what? 0 and 1. Cool? Now, the very last one is tricky because I have solid dots and open dots. So it looks something like this. Okay. So in this case, it is all real numbers except 2 because the domain still exists here because I have this solid dot. It just jumped. Okay? So it's going to be all real numbers except 2 because at 2 I have this open circle and there's no. Okay? And then my range is going to be, my range is going to be -2 union 0 to 3. Okay? Because there is no value for y between -2 and 0. There's a big gap, right? There is no value. Everyone go with that? Where did I get 3 from? So this dot here is the ordered pair 2, 3. Okay? Yes, sir. Okay, so when you're doing domain and range, you're looking over the whole graph. You're not just looking at start and stop of the graph. So the highest point of the graph is what? For the range. What's the highest range? 3. No, it has a stop. There's no arrow. Oh, I see what you're saying. So then the domain, yep. So the domain would be -5. It would be -5 to 0. Sorry, -5 to 2 and then 2 to 4. Okay. Yep, I see what you're saying. Okay. Because there are no arrows there. Okay. So -4, 2, union 2 to 4. Sorry about that. Yes. It is a bracket because it's solid. This is a parenthesis because it's an open circle. For the range, it exists at both of those spots. This is a rounded because it's an open circle. Okay. Okay, going back to the check mark, it is all real numbers by greater than -3 except for 0, 1, 4, the domain, because it never goes past the -3. Oh, sorry, -2. I couldn't see the numbers on there. Okay, good. All right. So now you have a new paper. We are going to ignore the front right now because that's more domain and range from the graph. Does everyone have the new paper? Did you guys? Okay. I'm not going to do the front. It's more pictures. You're going to do that later. Okay. All right. So we are on the back of the paper. And we're going to pay attention to our rules. And here we go. Now, I can't factor this top part because there is no GCF. 3 and 10 have nothing in common. X minus 3. So my domain is going to be all real numbers except what can't it be? It can't be 3 because x minus 3 cannot equal 0 because I can't have a 0 in the denominator. And when I solve for this, that means x cannot be 3. You follow? All right. Looking at the next one, it's going to be all real numbers, but 6 and 1. All real numbers, but 6 and 1. And this last one down here, again, this came directly from your warm-up today. So all real numbers except positive 1 and negative 1. Good job. Okay, moving to the bottom. Okay, what rule here? What's the rule that applies here? The 2 restriction. It can't be this can be 0. It can't be a negative. So x plus 4 must be greater than or equal to 0. Yes. Because of the square root. So x must be greater than or equal to negative 4. And it can't be, what number can't it be? So all real numbers greater than or equal to negative 4 except 2. You see how to do that? Good? No. What are we confused about? Ask your question, Asia. Okay, so we had 2 restrictions. Restriction number 1 is under a square root. It has to be a positive number. That's why I set this equation, because of the radical, equal to greater than or equal to 0, because that means it's positive. When I solve, I subtract 4 from both sides, meaning x has to be greater than or equal to negative 4. We can never have a 0 in the denominator. That's the other rule. So I set x minus 2 equal to 0 and solved and got 2. So x must be greater than or equal to 4, and it can't be 2. It'll have a hole there. Good, or an asymptote, break, something. Okay, so you are responsible for, there's 2 problems left on the back, there's problems on the front, and then I'm going to give you one additional thing.